Shruti, meanwhile, or Yash, meanwhile, please play the video of Tech a Month so that students can get insights what is all about Tech a Month.
Yes, ma'am. I'm sharing my screen.
Yes, it's not audible. Kindly reshare it and click on the share audio option while sharing. Reshare and click the check mark share audio.
Welcome, sir.
Welcome, sir. Bhav this side. And basically, we are really very happy to have you in the session. Soon we are going to start with the session. We're just waiting for till more 5 minutes so the other participants can also join and they can get a great insight from you. We're really happy to have you, sir, today in the session. And it's really a wonderful opportunity for all of us, all the students, to interact with you and get a great amount of insights and knowledge from you. And I can say that today we are having a DSA guru with us. Abhishri, you can start at 19.5, right? 7.5.
Yes, sir.
Good evening, everybody.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, sir.
Can you hear me?
Yes, sir.
Yes, sir, you are on.
Hello. The session started. Actually, I'm unable to hear from your side. The problem. No, your voice is not on. Shall I leave and join again?
Sir, kindly can you confirm? Are we audible? Hello, hello.
Sir is having some problem.
Professor Sir is joining again. There was some technical issue.
Okay, okay, no issues. Participants, soon we are going to start with the session. There is some technical glitch. So guys, before that, let me share some great insights with all of you. Yesterday, it was the day when we inaugurated TechAmonth 3.0. Already, most of you must have attended TechAmonth 1.0, TechAmonth 2.0, and it was definitely a big success. A story of
Guys,
10,000.
kindly wait. Sir is joining within a minute.
Yeah. So, am I audible, Manas?
Yes,
Abhishek, am I-
you're. Yes,
Okay,
we are.
so we started TechAmonth 1.0 with a journey where our motive was basically to bring information regarding so many good technologies in the market and entertain people, students about different technologies. And today, it is the day that we are here with one of the great speaker. Soon he'll be joining us as there is some technical glitch. But definitely, I believe that he's one of the known and the most famous personality, having great amount of student interaction or a student fan following regarding DSAs, coding and all. People from CSA definitely, Abdul sir, I know that he's love for all of us. So we'll be having him very soon. But before that, let me give you a bit of glimpse what is TechAmonth 3.0 and what IEEE Chandigarh University student branch is basically doing. Till that time, technical team kindly keep admitting people, right? So guys, yesterday we started with our inauguration and I'm really glad and happy to share with you all that the inauguration was really marvelous. We had so many dignitaries from different fields having great expertise in different fields. Whether I talk about speakers like we have Narayan sir, and we have basically we had so many great speakers. We had Lieutenant General, even though we had our Vice Chancellor sir of Chandigarh University. He started his session with a great introduction about Chandigarh University, how we are achieving different rankings and all, including that we got so many great insights from the speaker that how we can think positively, how we can think in different way. That inauguration was definitely the marvelous inauguration. We had student interaction, and today it's the second day when we are marking basically the start of our event or technical events, which I should say about DSS and all. So this will be continuing for 30 days, but sessions are definitely going to be the most best sessions because we are here to provide you best speakers from around the globe. When I talk about best speakers, there are so many hidden speakers. I'll not be revealing their name. Go to our website. Technical team kindly post the website link in the chat section. Go to our website, see our website. Manas, as soon as sir join, kindly let me know, right?
Sir has already joined.
Okay,
Yes.
okay, sir. Sorry, sir. We are really happy to have you in the session. So over to the anchors.
So, most welcome, sir. A very good evening to one and all present here. This is your host Abhishek Dhyani and Adan Malik, welcoming you all who have gathered here to grace our session Byte the Bullet. On behalf of IEEE Chandigarh University Student Branch, it's my great pleasure and first and foremost duty to extend a warm welcome to everyone present here.
TechAmonth 3.0 is a month-long event that focuses on technical events such as research papers, patents, web development, Android development, aiming to help students enhance and enrich their skills in the domain they want.
This event is being powered by AICTE Spices Scheme and IEEE Student Specs under the auspices of Asia's largest technical event, TechInvent 2022.
So first of all, we are extremely privileged to welcome Abdul Bari sir, who is currently the CEO of information and technology firm NBH, Hyderabad. And moreover, he has developed one of the best learning resources for data structures and algorithms. Sir, your learnings, your teaching, your experiences have always motivated us to work harder. Thank you, sir. And we are much obliged to have you here.
We are also exhilarated to have with us all the department heads and faculty members for their valuable time by gracing our session with their presence. Now, I'd like to cordially invite Ms. Sugandha Sharma to please come forward for the welcome address.
Thank you, everyone. And before I start, welcome, sir, to the one of the most vibrant student branch of IEEE Chandigarh University. And I feel really honored to welcome you on behalf of Chandigarh University. So I am very new to this trend-setting things of students, and I'm just loving the way the students are sharing their status with us. The DSA Guru is here with us. So thank you so much. And on behalf of Chandigarh University, the stage is all yours. Please delight our students with your handful of knowledge. Thank you, sir.
Can I now please request Abdul Bari sir to come forward and inspire us by their motivating words?
एक second, हो गया, अभी हो गया. Now, am I audible now?
Yes, sir, you're perfectly audible.
Achha. One more thing, how to share my screen?
Sir, there will be a green color share screen option.
Okay, I got it. Now I got it. It was not active till now. It's active now. Yeah, good evening, everybody.
Sorry to interrupt, sir. Please check you are having the co-host rights. With your name, it is written co-host.
With my name, no, it's not written. On the, that is thumbnail window, na?
Yeah.
No, co-host is not
Technical
there.
team, please check once.
Yes, ma'am. We have provided the co-host right to sir. Now he can share his.
Yeah, it's active now. I can share the screen.
And so now you are share anything, right?
Yeah. So let me start the session. I'll share the screen. Yeah. Here the topic is data structures and algorithms. That is the importance of data structures and algorithms and how to prepare. What is the importance in academics and what is the importance in industry and application development, and how you should prepare for this one. I'll give you the idea. Like what I know is that most of you are in second year or second year students. So this is very important that you know what you have to do in other in your entire course. So what are the other core subjects also you have to focus on, but the primarily is data structures and algorithms. So let me talk about the topics that I'm going to cover. See, I'm going to cover the topics. I'll start from the basics. Actually, see, I believe in talking. When I talk about something, I should give you the background perfect. So I should involve you in the topic first of all, then you can understand it better. So that's what. So I will start from how a program runs. This is a very basic thing, but the way I'm going to cover is entirely different. Then I'll explain that. I'll give you the difference between data structures and databases. What is the difference between them? So you get the clear picture what actually data structure means, right? Then I'll talk about some of the types of data structures and I will compare them. I will talk about the time complexities a little bit. Then also I will explain you how you should, what are the things that should focus on while learning programming and how to prepare data structures. And then lastly, I will talk about the algorithms. Okay, this I have to do it very quickly in 1 hour of time or 45 minutes of time, I think. So let us start. Very first thing is, I don't have the diagrams. I'll be drawing them and explaining you. First thing, how a program runs. For that, I should draw the block diagram of a computer. That is actually taught in the first year. or the first class of your programming. So in block diagram of a computer, we draw CPU that actually executes your program. Second thing is main memory. Main memory. This is also called as RAM. All right, in mobile phones also it is the same thing. You have the processor, CPU, and the RAM, right? That is main memory. Then you have on your computer system, you have hard disk drive, right? And this, we call it as a storage or a permanent storage. On your mobile phone, we call it as storage. Like when we buy a mobile phone, we want to know how much RAM it is having, 3 GB, 4 GB, 8 GB RAM it is having. Then the storage is 32 GB, 64 GB, or 128 GB, like that. That is the storage. So this is the permanent storage. So in our computer system also, we have a hard disk. That is nothing but a permanent storage. All right. Now, these are three main components, three main components. That is CPU and the main memory, and then the storage. Now, first, I will talk about the storage. What will be there on the storage, right? On this, we store the things in the form of files. And there are two types of files. One type of files are program files. And the second type of files are data files. So I'll explain you what does it mean. See, if you are running a notepad is nothing but a program. So program is available on your hard disk in the form of a file. When you double click an icon of a notepad application will open. So actually it's a program. So actually it is there on your hard disk. So it is in the form of file. And in notepad, you can open various text files. You have various programs like Java programs or some other thing you have. So that is nothing but data file. In the same way, I'll take one more simple example. Suppose you are opening media player for watching movies on your laptop. So media player is nothing but a media player. In short, I will call it as MP. That is nothing but a program. But after opening the media player, you will open some movies. So those movie files or audio files are nothing but data files. So from this, we can understand clearly that on your hard disk, everything will be in the form of files. And there are two types of files. One is data file, other one is program file. So both programs as well as the data that is used by the programs, both the things are kept on the hard disk. This is very important thing. All right. Now I have another heading. So now I will show you something. See, the same diagram, I will be drawing it quickly. Now this is RAM. This is hard disk. All right. Now let us take one program that is media player, Windows media player. Okay. WMP in short. Suppose you want to run media player. Okay. Then that is a program file available on your hard disk. So who will execute that program? CPU will execute the program. So keeping the program on the hard disk, it cannot be executed. The program should be brought into the main memory. All the instructions of that program should be loaded inside the main memory. It should be loaded inside the main memory. Then CPU can start executing that program line by line, or as the instructions are. If loops are there, it will be repeating. If functions are there, it will be calling them. So, but the program should be brought inside the main memory in machine instruction from, then only the CPU can execute it. So RAM is used for running the programs. So the programs will come inside the main memory. This is the very important thing. Now, next thing, very next thing. You want to watch a movie in this media player. So you have one movie file available on your disk, right? Let us say PK file is there, PK movie file is there. You want to watch this movie. Now, this movie file is on the hard disk. Being on the hard disk, it cannot be played. The file is on the hard disk, it cannot be played. So this also has to be brought into the main memory. This also has to be brought into the main memory, just like the program. Now, what is this movie file? Movie file is nothing but data. So when you are bringing this PK movie inside the main memory, then only this program, this media player program can play this movie data. All right. So how many things are there in the RAM? The program is also there in the RAM. And the data is also there in the RAM. Now, what data it is? It is a movie file. So it's containing what? Audio and video information. It is containing audio, video data. And the media player knows how to read the data and display it on the screen. And it is displaying it. So when the data is brought inside the main memory, movie file is a huge file, maybe in GBs. Now that file has to be stored in the RAM inside main memory. So that is not small value, 1 or 2 values, right? Like the marks of 3 students or 5 students or the marks of 4 subjects. It's not like that. Or for adding 2 numbers, you are taking 2 numbers in your program. It's a large size data. That video, audio, video data is large size data. Now, when it is kept inside the main memory, it should be utilized by this media player. It should be arranged inside the main memory such that it is perfectly utilized without lagging in the playing of movie. Right? So how this data should be organized inside that main memory, that is nothing but data structure. Data structure. So data structure is arranging the data inside the main memory for the utilization by the program. When the program is running inside the main memory, then the program needs the data not on the hard disk. Program needs the data inside RAM, inside the RAM. Now, how it should be arranged such that the program utilizes that data efficiently. Efficiently means what? For media player, there should not be any logging, and there should not be a difference between the audio and the video. Lips should be syncing properly with the audio. Then it is perfect, efficient output, right? So for efficiency, data should be kept properly, right? So what is data structure now? Arranging the data inside the main memory during the execution of the program. Now the question is where the data is usually available. Where the data is available. Usually data may be available on the hard disk, or I will introduce one more thing now. Data will be available on internet. It may be coming from internet. Nowadays, most of the things are coming from internet. Now, if you are playing any movie from internet, that should be loaded in your computer system, means it should be brought into RAM. Then only your media player can play it. Keeping it on the internet, a movie cannot be played. It has to be brought into RAM. Right? So when it is brought inside the RAM, how it will be arranged? So the arrangement of that data, movie data, is nothing but data structure. I have taken the example of movie. It may not be just movie. Okay. It may not just be a movie. It may be any other thing. Like suppose you are downloading your results, or you are accessing the information of a student, you are accessing your bank data, or you're accessing your bank account, okay? Or you're browsing something on internet, or you are accessing your Facebook data, whatever you are doing. If you are using Facebook app, suppose app in your mobile phone, then that app should be inside RAM, and the data related to your account should be pulled from internet and kept inside RAM. Then only your Facebook app can show that data in your mobile phone screen. All right. Unless it appears, unless it is there inside RAM, it cannot be shown. Now the question is how that Facebook app will arrange the data, your account data, whatever the posts you have, videos also they are posted by your friends, or likes and shares and comments, all those things has to be there inside RAM, right? So how they should be organized inside RAM, there the role of data structure is. If I open my Facebook, you can see my video also. Can you see? You can see my video also, right? So I am opening a Facebook. Yeah, I am opening Facebook. Now, I have opened Facebook app. I will open it once again. The moment I touch this app, it is loaded inside the main memory. Now, whatever it is showing, that data is coming from internet. Now, if I scroll, you see it's keep on showing. So fast it is coming from internet into my RAM and then displayed on the screen. Without coming on RAM, see it was stuck up because it was taking time for loading. Now, okay, for loading it is taking time, no doubt. But when it is brought inside RAM, it should be quickly displayed on the screen. So without bringing into RAM, it cannot display anything on the screen. This you keep in mind. Okay. So the data that is used by an application must be inside RAM. So I have explained you one important thing, that the data is outside RAM. It should be brought inside RAM. Then only program can use the data. Now, coming to the next thing. Again, I have to draw the same diagram for explaining something new. This is RAM. Now, have you heard of databases? If you are talking about the large size data related to some organization, like the data about college students and the courses and the examination, everything, that has to be organized on the storage, on the hard disk. Mostly it is done using a relational database management system or object-oriented relational database management system that are being used mostly, and the data will be in the form of tables. Data will be in the form of tables. If it is in the form of tables, then we say it is RDBMS, okay, relational database management system. So this data is organized in the form of tables where it is stored. It is stored on the hard disk storage. It's on the storage. Now, here also the data is organized on the hard disk such that when you give a query, suppose you want to fetch the details of one of the students, quickly you get the data from the hard disk into RAM, then it is shown onto your screen. Okay, the program which is pulling this data should be able to quickly pull the data, bring it into RAM, then display it on the screen. It should appear on the screen. So the data is organized on the hard disk also. Now listen, now this statement is important. Organizing the data on the hard disk for its efficient utilization is nothing but databases, database, DBMS. And organizing the data inside RAM for the efficient utilization by the program is nothing but data structures. This is called as data structure. This is the difference between data structures and databases. All right. So data structure comes into picture when you're running the program. So it is a part of a program. Database is outside the program. That's on the hard disk. It may be on the hard disk or it may be on the hard disk available in internet. So we say it's in the internet. Internet is also collection of machines having hard disks. So data is stored on the permanent storage only, but we are pulling via network. Okay. So this is the difference between arrangement of data on the hard disk for its efficient utilization with databases, and inside RAM during the execution of the program is database. The data structure, that is data structure. All right. Now, next. Now, next thing is types of data structures. I told you that arrangement of the data inside the main memory is a data structure. Now, what are the type of data structure? First type of data structure is array. This is commonly available in every programming language. Like in C language, if you say integer array of size 5, you get an array of size 5, and you get the memory. Suppose the integer is taking 4 bytes of memory. This is 4 into total 5. This is 20 bytes of memory. And it is treated as 5 integers. This is index 0, index 1, index 2, index 3, and index 4. This is how we utilize the memory. You are very familiar with this one. So this array can store collection of values. Collection of values. Like, okay, see, I was talking about media player, video. If you're playing a PK movie, video. So video is nothing but collection of pictures. Collection of pictures. They are played very fast with a higher frequency, smoothly, so it looks like a movie. So collection of pictures is nothing but array of pictures only. Array of pictures only. Here in our example, I am showing array of integers, but in a media player, you need an array of pictures so that your media player go on showing them on the screen with a higher refresh rate. All right. So array is the very basic data structure which is used for storing collection of data, that is large size data. Then the second data structure is linked list. So this is a dynamic data structure, which is a collection of nodes where this will contain data. And again, one more node, this will contain the data, right? So this will contain data. Now there are two nodes containing data. In array, if you say this contains data and this also contains data, so two data is side by side. But in a linked list, they are not side by side. So we will have a link from one node to another node. So that's why we call this as a linked list, right? You may be learning it, just I am giving little introduction about them, okay? So this is the first node. Now using the first node, you can fetch the data, move to next node, you can fetch the data, you can move to next node by taking this link and fetch the data. So this is how it's a collection of nodes linked together, just like the bogies of a train are connected together. They are connected together, and you can join more and more bogies to a train, right? And you can remove the bogies also from the train. Now, a train is starting from Kanyakumari with 10 bogies. When it reaches Hyderabad, it becomes 12 bogies because passengers are more. Then again, when it reaches Bhopal, there are again 7 bogies because some passengers have unboarded at Bhopal. So the bogies may be adding and removing. So the same way the linked list works. So if you have data increasing, then we will be go on increasing the size of a linked list. And if the data is reduced, we will be go on reducing the size of a linked list by deleting the nodes. This is how the dynamic data structure is. Now, based on these two, array and the linked list, these are the two main things. If you are learning data structures, you must be good at arrays and you must be good at linked list. You must be good at linked list. All right, you should know everything about linked list, thoroughly about linked list. All right, you should be able to program it. You should know about its operations thoroughly, and you should know about its efficiency. And in my experience, I have seen that when the students are learning data structures in academics, they face difficulty when the topic reaches linked list. And they lose interest in the subject at that topic only. And this is one of the beginning topic covered in your academics. And if you lose interest there, then you will not understand rest of the topics. Maybe stack and queues, everybody understand. Every engineer in the world knows what is a stack and what is queues. This is a very basic thing. The rest of the things are difficult for them, like trees, graphs, and hash table. They face difficulty because they already lost the interest in linked list. Right? So make yourself perfect in linked list. You have to spare some time from your side, and you have to do some paperwork, pen and paper work. Do it by yourself, then try to write on the programs on linked list. You feel comfortable, then everything is easy. And actually programming itself become easy for you. Programming becomes easy. So this is the very important area where you should practice on. Linked list is very important. Now using linked list, I have to use eraser. Okay, I'll remove this. Yeah. Now, if you talk about the other data structures, like stack is there, it is implemented using array only. That works on discipline LIFO, that is last in, first out. Okay, the elements are inserted from one end and deleted from same end. Now, what is this and all? You will learn it. Okay, then queue is one data structure. This is one more commonly used data structure. Like suppose you are making a phone call to your friend. Today, that is not a problem. Like some 20 years back, 10, 20 years back, there used to be a problem. If you make a call from landline phone, we used to get a message that all lines in this route are busy. Please wait or call again later. Like, okay, nowadays you find this one. Suppose you call some customer care service and you will be connected to IVR, right? In that IVR, you will have some options and you say that I want to talk to the representative Then they will say, then you will get a message. You are in queue. Please wait. Your number is third number or fifth number, whatever the number is. So you are waiting in a queue. So actually that IVR is nothing but a software. So it is making you wait in a queue. So queue is one of the data structures. So what is queue? Whoever came first will be served first, right? So whoever came in the queue first will go out from the queue first, in other words. So it works on first in, first out basis. So elements are inserted from one end and deleted from another end. So you can say they are inserted from this side and deleted from this side. So this is one of the commonly used data structure for developing applications. For developing various applications, stack is also useful at some places. Okay, so where stack is useful, it will take time for to learn it. Right? In one example, I cannot explain you, and even if you start searching for it, it will take time for you to understand about the stack. Okay, so go slowly on that. Queue already have explained you now. This is sufficient. What is the use of queue? You can understand it now. So there are various examples where queue is useful inside application. So I was showing you that CPU, RAM, program running here. Now this program is an IVR program. So it has to make the customers wait in the queue. So the data structure that it has to use here is what? Queue data structure. So the data about the customers is kept inside the queue, right? Queue is nothing but you implemented using array or linked list. It is implemented using either array or linked list. But IVR program will be using arranging the data in the form of a queue. So that's how queue is a data structure. Okay, now you can see that program means data structure to arrange its data. So one of the known data structure is queue. Now one more point I will tell you before going to the next one. I told you that program will arrange the data inside RAM, and that arrangement is called as data structure. You should know what are the ways of arranging the data structure. Data means what are the ways of arranging the data. That's what we are learning. That's what we are learning it as types of data structure. What are the various ways of arranging the data? If you know about the known types of arrangement of data, then you can think of designing your own data structures also, right? Depending on the applications, you can design your own data structures also. All right. It is just like I am showing you about the ingredients and showing you how to prepare 4 or 5 dishes. Then using same ingredients, you can introduce a new dish also. You can try out and prepare a new dish also. The same way, when you learn about these data structures, you are learning about some commonly used data structures. All right. Using them, you can design your own data structures also by taking the combination of them, or you may have your own new ideas.
Sir,
Yeah.
Sir, sorry to interrupt you. Definitely, I believe this session is going really good, and there's a great sync between participants and you. But sir, just we are going to pause you for a minute, and definitely I would like to welcome our Dean Academic Affairs, Dr. Shant sir, to share his few words as a blessing for all of us. Please, sir.
Yeah, sure.
Vaibhav, sorry to say, I'll be throughout the session. Don't worry, I'll be sharing my blessings at the end of the session.
Okay, wonderful.
It is going really wonderful, sir. Because sessions are really interesting. I am also listening to you. Thank you so much for this time. And I'll share my words at the end of the session, Vaibhav.
Sure, sir. Thanks a lot, sir. Over to you, sir, please.
Thanks. Yeah. So I told you that stack and queues everybody knows. Now there is one more arrangement of data. This is important. Tree structure. So the data is organized like this. Now this is again a linked list only. Data is kept here, and data will have its left child, and this will have its right child also. Again, here the data is kept. Again, it will have its left child, and also it will have its right child. Okay. Again, the data is kept here. Here also data is kept. It is having its left child and right child. So it's just like a hierarchy of some organization or a family tree, like the data is organized. Like this is grandfather and his children and their children and so on. So the data is organized in the hierarchical structure. What if your application demands the arrangement of data in the form of this structure, you can use it. Otherwise, this type of data structure is very useful for search operations. It's very useful for search operation. And this type of data structure is called as a binary tree. Binary means if every node is having 2 children, then it is binary tree. Okay. It can be n array tree also, like every node is having n children also possible. But most commonly used one is binary tree. There is something called as B plus trees also, like they are n array trees. Means one node can have many children. All right. It can have more data, not just one value. It can have multiple values as well as multiple children. So data is organized in the form of a tree-like structure so that the searching or accessing of the data is very fast, very fast. How? I will explain that in next slide. But just here I am giving you what are the types of data structures. Okay. So now from this slide, we can understand that array and linked list, these two data structures are very important. You should understand about them much thoroughly. Then other data structures, learning about other data structures will be easy for you, and coding them is also easy for you. Okay, I have just given few names of the data structures here. Like you can see, there is a list of data structures already I have, and I am mentioning that these are two physical actual data structures inside main memory. Then logical data structure means how you utilize them is logical data structure. Like, what is this? What is this diagram? Okay, I think it is a little congested. I'll remove few things from on the screen. Okay, now if you see this one, this picture, what is this? This is nothing but an array. So this is a physical data structure array. But I said that we will insert the elements in a FIFO fashion here. Suppose 5 came in first, 5 goes out. If I'm inserting new element 10, it comes here at the end. Elements are inserted from right hand side, deleted from left hand side. So we are following FIFO. This is nothing but Q. This is nothing but Q. How Q is implemented? Using array only. Using array. So actual data structure is array. And how you arrange the data inside that, how you insert and delete, that is nothing but queue. So the behavior is like a queue. Array behaving like a queue. All right. So physical and logical. Physical and logical. All right. Like if you take a car, private car, or personal car, cab, taxi, or bride's car, right? Same thing, used in a different way, it behaves in a different fashion, right? It behaves, same thing behaves in a different fashion. So the same way, array, same array can be used as stack, as a queue, as a tree, as graph, as hash table also. It's an array only, but same array can be used in a different way. Now, if I talk about a linked list, then see this one. Now, this is a linked list. A node containing 5, a node containing 7, a node containing 6. Now I want to add one more node. So it is added here only, this side only. 10. If I want to delete, 5 will be deleted because that came first. So if I do only first one and insert only at the last, I am following FIFO. But actually it's a linked list. But it is following a discipline of FIFO. So using linked list, you can make a stack, you can make a queue, you can make a tree, you can make a graph, you can make a hash table. So primarily is what important? What is important? Array. Array you can learn in first year itself. First time when you learn about programming, it's easy. But linked list, you face difficulty. So I again stress on the point that spend time on linked list. Okay. Now coming to the next thing. Now next. Now, this is important. Operations on data. Sorry, operations on data, or actually operations on, it should be operations on data structures. It should be operations on data structure. Let us take array. If I take array, okay, 0, 1, 2, 3, 4, 5, 6, 7. I have some elements, 8, 3, 9, 5, 4, 2. Now, I want to insert one value in an array. Add one more value to an array. Insert. The question is where you want to insert. I want to insert at the end. Okay, insert it. No, I want to insert it somewhere in between. So I want to insert after 9. Then there is no space. What I should do? I should move the element 10 here, and this will become 2, and this will become 4, this will become 5. Now there is a free space here. I can insert a new value 12 here. So it is just like students sitting on a bench. Now I want to join you. So there is a free space at the end. You can sit there, or I want to sit somewhere in between. So other students should move, then shift the place. Then only a free space is made for me. I can sit there. So this is how insertion is done. Insert means writing a new value inside a data structure. Insert. All right. So let us take this as an array. Okay. Now next thing. Next operation is search. Now the question is why you have arranged those values in an array, why you kept them, so that whenever we want, we can retrieve the value, we can see the value, we can fetch the value. So that is nothing but looking for the value. Search. Search. Like I want to know what is the value at a location index 5. So if I go there, I got the value 4. Now I want to know where is value 9. I can search. Like this is 8. No, this is not 9. 3. No. Yeah, I got the value 9. Here it is at index 2. So we insert the values so that if we require them, we can take the values. So we search them. So the most primary operation is search. In entire computer science, the most commonly performed operation is search. Like Google search, or on your Facebook, you will look for some post, that is again search. And if you are in a LinkedIn account, you are looking at somebody's profile, that is again search. So most commonly performed operation is nothing but search. So we store the values so that we search and retrieve the data. If you want to know about some data, we retrieve the data. So insertion is adding new thing, and search means looking up for something. Then sometimes we perform the update operation. Like first value is 8. Let us make it as 20. So this is updating. Then delete. I want to remove the value. Like suppose you are closing your Facebook account, you are closing your Google account, or you have a paid Netflix account, so you are deleting the account. So like that, if your user is deleting from the database, it should be deleted. So in data structure also, we delete the data. Like suppose I told you that in the beginning, you are watching a movie. So movie frames are being filled inside an array, suppose. Now your media player has shown this picture, this frame, and this frame, and this frame. Now more new frames are needed that are coming from the hard disk to RAM. Now what about these frames? They are already played, remove them. New frames are added here, new frames are added, and old frames are removed. So insert is also there, delete is also required. Like the customers are waiting in the queue. Now one of the first customer is served by the customer care representative. Now remove him from the queue, his work is over. So deletion is also there. A new customer is joining in, so he is inserted. So insert and delete both are there, right? So insert, delete, update. Like search, I wrote it 2 times. So the major operation is search, all right? So for understanding data structure, now once again, I will repeat the statement. Okay, I do it like this. Our programs run inside main memory. Whatever the data used by the program should be inside the main memory. So the arrangement of this data inside the main memory is called as a data structure. Data structure. The program utilizes this data. How it will utilize the data? How it will utilize the data? It may be inserting more data inside this one, deleting the data from there, updating the data there, and searching the data from there. So when the data is in RAM, the program performs these type of operations. Data means not just one value, collection of values. Imagine it as collection of values. So those collection of values, these are the type of operations performed upon collection of data. Which operation? Insert, delete, find, search. Insert, delete, search. Okay, update and search. These operations are performed on collection of data, collection of students record, collection of Facebook post, collection of LinkedIn post, collection of video frames, right? Video frames. So it may be a collection of anything. So on collection of data, these operations are performed always. Remember this one, right? You can remember for now, for always, you can remember it. The operations performed on a collection of values or collection of things is that you insert a new thing, you delete something, you update something, you search for something. You have collection of dresses at home in your almara. You buy a new dress, you insert. You want to give away one old dress and delete, right? And you want to do some changes on some dress, like you want to add some sticker or something, that is update. Now you want to wear some new shirt today in party, tonight in party, you will search for that dress. So if you have collection of something, you perform these operations. You have collection of books in your almara. You bought a new book, you insert. You want to give away one book to some friend, delete, right? You want to read some books, so you will search for the particular book that you are looking for, all right? And you want to change the binding or cover of a book, so that is update. So you perform these type of operations on collection of something. So the collection of data also, these type of operations are performed. On collection of data also, these type of operations are performed, all right? So operations on data structure. This is over. Now coming to the next topic. Now, next important thing is, when we talk about those operations, what are the operations? Just now I told you that is insert, search, okay? These are the two important ones. Let us take these two. When you perform these operations, the time taken for performing the operations is very important. The time taken is very important, okay? So you should know what is the time taken for performing these operations upon array, upon linked list, upon trees and graphs. The time is different among all these. The time is different for performing the operations. The time taken is different, okay? So in this, we can't say that tree is faster or array is faster. We don't select that. They have their own time taken for performing the operation. Depending on the requirement, we use either array or linked list or trees or graph. All are used. All of them are dependent on the requirement you have. So I'll give you the idea about some insert and search operation upon these data structures, okay? Let us take an array. Let us take an array, okay? Now I have some values, 6, 3, 9, 4, 2. I want to insert a new value at the end. Just go and insert there. How much time it has taken for me to write this one value, 10, one amount of time? How much time it took me for writing these set of values, 6, 3, 9, 4, 2? That time was, how many values I wrote? 5. It was 5. If I say I am writing n values there, so you can say n time. For inserting n values in an array, n time it takes. For inserting one value in an array, it takes just 1 unit of time. 1 unit of time. Okay. See, in the example, when I'm drawing it here and showing you, I am inserting 5 values. But imagine in your program is going to insert some values in an array. How many values it will be? Array storing some n values, right? N values. So we say n values. Now, listen. I want to insert a new value at this place. There is no free space at this place. I should shift this 10 to move to next place, 2 to next place, 4 to next place, 9 to next place, 3 to next place. Then I get a free space here for inserting a new value, example 12. Now for inserting an element at some place, how much time it has taken? I have to shift the element. So that time is taken extra. How many elements you are shifting? In this example, I am shifting 4 values, 5 values, but not based on the example. In general, how many values you may be shifting? From the place, after that, as many values are there, that many values you have to shift. How many may be there? We don't know. So we say some n values, n number of values. So the time for inserting at some place takes how much time? Order of n time. If you insert at the last, it was order of 1. But you insert somewhere else, the time is order of n. Why n? Shifting of elements. See here, actually n means linear time, linear number of elements, right? N, linear. So the time is linear. So it is taking order of n time for moving the elements. Now suppose I want to search here. This I'm talking about array, okay? I want to search for element 2. So is it element 2? No, it's 6. Is it 2? No, it's 3. Is it 2? No, it's 9. Is it 2? No, it's 4. Is it 2? Yes, found. How much time it has taken for me to search and find out that value 2? Right? So I have to search linearly. How much? Some number of elements. Don't say 5 or 6 as per this example. I have to search for some number of elements. So the time for search is also how much? Order of n in an array. So in this way, you should analyze how much time it is taking for searching in the array, inserting in an array, and updating in an array, deleting from an array. You have to study this one. Already you have to study this one. Now coming to next, if I have a linked list, if I have to have a linked list, okay. Now, suppose this is the first linked list. See, in a linked list, suppose you have the values 6, 3, 9, 4. Then if you want to reach 4, you cannot directly go on 4. You should go to first node, take the address and go to next node, take the address and go to next node, take the address and go to next node. This is how you should follow. All right. You cannot directly go on the last node 4. Now, in a linked list, suppose you want to insert a new node here. How much time it takes? I will insert a new value, 10. How much time it takes? I should create a new node and link this one. For linking this one, I should come here. I cannot come here directly. I should come from this place, move, 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 and then go on this node and link. Nodes are not moved. I am moving upon the nodes. Okay, I am jumping upon the nodes. Like you think like that, these are the stepping stones. So moving upon the stones, and then you are going on that last node, then linking the new node. How much time it takes? It takes order of n time. Oh, it's time's up already. Shall I continue?
Yes, sir. Yes,
Sure.
sir. Please continue.
Okay, okay. So it is taking order of n time. Just now in array, I have shown you that if you are inserting at the last, it is taking order of 1 time. But in a linked list, it will be taking order of n time when you insert at the last. But if you insert a new node in the beginning, like 15, just link to this one and move the first pointer here. It's easy to insert on the left-hand side in a linked list than on the right-hand side. Okay. See, one more thing. Listen one thing. You are just having a glance of the data structure. You are not learning data structure. So what you have to take from this session is that time is important. Okay. It incurs some time when you perform some operation. And the amount of time taken in array or linked list is different. That's enough. This is what I want to convey. I'm not teaching linked list. I'm not teaching array. Okay. This is what the point that you should take. The time operation performed on the different data structure, the time will vary. That's all. Now, let us see one more, last one from this slide. Okay. And then I have a few more slides. So then we will okay. Now, if the data is arranged like this, 30 is on this side, 20, which is smaller than 30 is here, 10, which is smaller than 20, it is here. 23, that is greater than 20, so it is here. Then 40, which is greater than 30, so 42, so that is on this side. Then 36, so it's greater than 30 but less than 42 is on this side. Then 55, which is greater than 30, greater than 42, and greater than 42, so it is on this side. The data is organized in the tree form. How many elements? 7 elements. Take it as almost 8 elements. Okay, take it as 8 elements, not 7. Just one more from my side. Add it, 8 elements. Okay. Now see, I want to search for 36. So I can start from 30. This is 30. 36 is greater than 30, so it should be definitely on the right hand side, not on the left hand side. I'll go on right. This is 42. I'm searching for 36. 36 should be definitely on the left hand side of 42, not on the right hand side. So I'll go on left hand side. Yes, 36 is found. So in how many checks I found this one? How many comparisons? I found this in just 3 comparisons. I found this in just 3 comparisons. If I am organizing the data in the form of a tree such that the small value on left side, large value on right side, this is called as binary search tree. So this is a binary tree only. And this type of arrangement is helpful in searching. So in how many comparison I got the value? 3. In this tree, if you search any value, maximum it takes 3 comparison. You search for 10, it takes 3 comparison. If search for 55, it takes 3 comparison. You search for 39, then also it takes 3 comparison. This is 30. 39 is greater. Go on right side. This is 42. 39 is smaller. Go on the left hand side. 36. 39 is greater. Go on right side. There is no node. Stop. Element is not there. So when the element is not there also, it is taking maximum how many comparison? 3 comparisons. Log 8 base 2 is how much? 3. So how much time it is taking? Log 8 time. Actually 7 nodes, I said take it as 8 nodes. So say n nodes. So if there are n elements, how much time it takes for searching? Log n time. So just now I have shown you that in array, searching takes order of n time, but in a binary search tree, searching takes how much time? Log n time. So who is faster in searching? Binary search tree is faster than searching compared to arrays. So I have shown you 2 data structure, 2 to 3 data structure. Then I am saying that for searching, binary search tree is faster. But one more thing, always binary search tree is not the solution. Now you say, don't use array whenever you are searching, use binary search tree only. No, that is not the answer. If suppose you are searching, it depends on how you are searching. What's the behavior of searching? What type of values you are searching? So there are a lot of things that you'll be learning when to use which data structure. This type of sense you must have, and it takes time to learn. Okay, in one day you can't learn it. If you spend time on them, then you will learn about them. Okay, so the difference I have shown you that some data structures are faster in operation, some data structures are slower in operation. It doesn't mean that slower data structures are useless. No, they are using some requirement, the others are using some other requirement. Like sometime if you want to travel from Delhi to Kanyakumari or Chandigarh to Kanyakumari, sometime you take train or sometime you may take flight. So it's not that always flight is the only solution. No, that depends on the requirement. That depends on your budget. That depends on the time. So that's nothing but requirement. Budget and the time is your requirement. So there are different data structure. Which one to use is dependent on the requirement. So this takes time for understanding and getting the sense which one to use then. So what is the important thing among them is the efficiency. One of the thing is what the time taken by performing, the time taken for performing operations on the data structure. So the time is one of the factor of your requirements. Now coming to the next slide. Yeah. Okay. Now see, linked list is one data structure. Trees is one data structure. Graphs is one data structure. Hash table is one data structure. All right. Now listen, the very important thing, very important thing I'm telling you. All these are data structures used in your program. So these data structures are related to programming, coding only. Now the question is, you have to write down the code for creating a linked list, inserting, deleting, performing all the operations upon a linked list. Yes, you should write down the code. There is no ready-made code available. For trees also, you must write down the code. For graph also, you must write down the code. For hash table also, you must write down the code. If you are using C language, you must write down the code for all of them if you are using C language. All right. And you will learn data structure only if you write down the code by yourself. You should write on the code for linked list. You should create it and use it. You should write on the code for tree, entire code, everything bit by bit. You must write down. Then only you will understand data structure. And for learning that, you will be using pen and paper. You will be drawing diagrams for analyzing them. You will be drawing something and sketches. You will be drawing and you will be understanding it thoroughly. Right? Then only. If you do pen and paper work and then do programming, then only you will understand data structure. Otherwise, it's just like a story for you. You are not an engineer if you are not perfect about the data structure. Means you don't know programming actually. It means if you don't know data structure, means you don't know programming. If you don't know how to utilize them, you are not a good engineer. All right. Then next, if you are using C++, it is having built-in data structures. It is having built-in data structure. It is having built-in classes like C++ is oops. So it is having built-in class for linked list. It is having a built-in class for tree or for graph, for hash table, for everything. It is having some data built-in classes. The names are different, but it is having the classes. Right? Like trees is called as map. Right? Trees are called as map in some and the hash table also there is a built-in class available. For everything, built-in classes are available in C++. Now the question is, will you learn about just the classes of C++ and use them? So there is no fun in learning data structure. You are just utilizing ready-made thing. You are not creating. You don't know how they are working inside. To know they're working internally, you must code those classes. So best language to use is C language because it's not having anything built in. Even you can use C++ for learning data structure, but don't use built-in classes like STL. Don't use those built-in classes. You write your own code. And Java is a cakewalk. This is having a lot of built-in classes for everything, built-in classes there. Array list, linked list, and for tree map, hash map, everything classes available there. Tree set, map set classes are available in Java. Just you use them. Whichever data structure is efficient for you, just you create the object and start using it. Only you should focus on what insert, delete, search. These are the operations that you have to perform. So without knowing the working of the data structures, you can use them. So if you don't know they're working, you are just a Java programmer. You are not an engineer, right? So if you are using Java, don't use built-in collection framework classes. You write your own classes for linked lists, whatever is taught, whatever you learn in data structure, like when you learn about linked list, node, links are there, it is connected to next one. Do that thing, everything, node you create and link and make the linked list by yourself. Okay, don't use built-in classes. In Java also, you can create your own, ignore the built-in one, you write your own. For most of the students, Java is very easy for them. They are comfortable with Java. So you can use Java or C++, or C is the best one. But some people think C is outdated because there is not huge demand of C programming, but C is still used. It's not dead. So you can use C also. Okay, then you can easily move on to C++ and Java. You can easily do that. So C or C++ is best option. And next is Java is a better option because if you don't know C++, don't waste time on learning C++ again. Use Java. Okay, if you know these three languages, first use C. I don't know C, sir. Okay, use C++. Sir, I don't know both. Use Java. Okay, then Python. Python is damn easy. Everything is built in. You don't have to worry about it as structure also. So it's not for engineers. Python is not for engineers. Python is just for application developers, right? Which application developer who have the domain knowledge? I'm an accountant, suppose. I want to develop application for myself because I know accountancy. I don't want to learn programming. I don't want to learn how computer works and all. Use Python and develop your application. All right. Suppose I'm a lawyer, I will need an application. Learn Python and develop your application. So Python is for everybody. Means for domain experts, not for engineers. Right? It's also for engineers. I'm not saying that for becoming an engineer, to understand the computer science and the subjects, you must know these languages, these conventional languages like C, C++, or at least Java. Java is also very damn easy compared to C++. right? Java is also for application developers, but most of the things are very useful that will help you understand engineering, right? Learn engineering. So then, okay, you should know some programming language. You should learn data structures, and then comes algorithms. You should know about the algorithms also. Okay, you should know about the algorithm. Then I was telling you in my diagram, from the first diagram, I was showing you databases. So without knowing about the database, how your application will get the data from database? So you should know database programming also. You should know database programming also. Then only there is a fun of writing algorithm. There is a fun of writing data, using data structures. If you don't have data in your program, then what is the use of data structure? You should have the data first. From where you will get the data? From the hard disk, from the database, or from the file, or from internet. You'll get the data from here. So you should know how your program will get the data from database or file from internet. If you know that, then you need the data, then you have the data in your program, then you arrange in some data structure. So data structure is useful only if you have data. But where the data is available? In databases. So database is also very important. You have to learn these things. Then next, what to learn in programming? In programming, the simple thing is what? Okay, first thing is you can use any of the languages like C, C++, or Java. Programming is very simple. Learning programming is very simple. See, learning how to drive a car is simple. In 1 month, you can learn and you can get a license. But when you have a car, where you want to go, it's a long time journey. Like, you want to go to office, you want to travel to other places, you want to visit other places, you want to visit hill station, you want to go on vacation. Now you should know the route, you should know how to drive, you should know how the roads are. There are many things to learn when you start driving the car. Really, you should have the traffic sense. But how to learn how to drive the car, how to control the car, you can learn it in 1 month, right? But how to use it, it's a vast learning process. Now, same way, learning programming is a job of just 1 week. Learning programming is a job of just 1 week. But by using that programming language, what you develop, it's a lifetime learning. It's not one-time learning. It's lifetime learning. Mostly students think that I have finished first year, I don't know programming. I have finished second year. You don't know programming means you don't know what to do using the programming language, right? You don't know that. But learning programming, don't say I don't know how to write program. Learning programming is damn easy. Just in 1 week, you can become a master in programming language. But what to do with that language? It's a lifetime. If you ask me, sir, are you perfect in programming? No, I'm not perfect in programming. Because it goes along with my life. I may be learning new thing tomorrow that I was not knowing today, right? So again, everything is there. Means it's a continuous process. Learning is a continuous process. I can't say that I'm master in programming, right? But do you know any programming language, sir? Are you master in some programming language syntax? Yes, I'm master in one of the language. I know all the syntax of some language, like C++. I know all the syntax. I know C language, all the syntax I know. I know the syntax, I know the language, but how to use it for solving the problem? I cannot say that I'm master. So I cannot say I'm master in algorithms, I'm master in data structure, right? A new problem come, you need a solution for that again. So again, you have to learn and do it something, okay? So there is a new thing ahead always, okay? So I am saying this because don't get discouraged that I'm not becoming master, I'm not perfect in this. Mostly students feel like this, and when they feel frustrated, they stop learning. So now I make it clear. Listen, learning a language means learning basic syntax, data types, how to write down the statements and all, printing, printf, scanf, scene, cout, right? The next is conditional statement, how to write if, less than, greater than operators, how to use them. Learn this perfectly. What is the use of less than? What is the use of greater than? Understand it. That is enough. Then learning loops, how loop works, how they work. That is important. Where to use loop? It's a lengthy thing. right? What are loops? How much time it take for understanding loop? Just 1 hour, 2 hours is enough for understanding what is loop. That's enough. How they work, that's all. In every language, they work in the same way with minor differences, if at all. Then how to write functions? What are functions? What are parameters? How to pass the parameters? How the function returns the value? That's all. What type of functions I should write? You daily write 10 functions. For lifelong, you can write on the function. There is no end. You can write on mathematical function. You can write on statistical function. You can write on accountancy function. You can write weather-related function. Many functions you can write. There is no end. But what are functions? What is the syntax? What are parameters and all? That you focus on. So you can become master in some syntax of a language. Then master in using that language is a different. Then lastly, most of the languages have OOPs nowadays. So you should understand what is object-oriented programming. So you should have the good concepts of object-oriented programming, like what are constructors, what are classes, what are constructors, what are accessor mutators, right? What are the different type of methods? What is polymorphism? So principles of object-oriented programming, you should be clear with. Then next, maybe last one. Then if you say, I will continue, otherwise stop. Last one is that how to learn data structure. This already I told you in my discussion that pick any one of the programming language to develop your own data structure. Your own data structure. You should code and develop your own data structure. Then solve as many problems as possible. The more problems you solve, that will be easy for you. Now, one more thing. Last and important thing. Very important thing. I'll tell you that actually I am from Hyderabad. So I took my family for North India trip, like Agra, Delhi, all these places. I took my family in my car. By road, I went there. But before going there, I already visited those places for conducting teaching sessions only. Okay, I used to visit. So wherever I visit, I used to visit all the tourist places and saw them. Then I took my family in my car there. So it means those places were known to me, right? They were known to me. Then after going to those places, maybe I have explored some new places which I have not visited earlier. So those places were known to me. Then it was easy for me to take my family there. Okay, I am also new to the place. They are also, my wife is also new to the place. Both will be worried, both will be new, both will be confused. Everything I know, then I can help my family to visit the places, right? Enjoy the journey. Got the point? Now, same way, if you have already experienced something, then you can do it better next time. All right. Now, the important point. Most of the students think that if you give one challenge to them, write a program for Fibonacci series, one program. They think and they try. Oh, I'm unable to do that. My friend has done it. That friend has done it. I'm unable to do. I am worst person. I'm not a good student. No. See, the time for doing some problem, to solving some challenge may vary. Like on a road, one car will go fast, one car will go slow. So it doesn't mean that you are not a driver. You don't know driving. Okay, don't compare with yourself first. Then second important thing here is that if you're unable to write a program, see the solution. One time you saw the solution. Next time when I ask you to write a Fibonacci program, you can quickly write it now. And if I give you a new challenge that is little twisted from Fibonacci, little change, you can do that also. But first time you must see the solution. Then only you are comfortable with that solution, and then only you can learn new things. So mostly student thinks that the program will come like a magic, directly come to their mind and they should be able to write on the program. No, it's not like that. If you experience this, then you can do it better next time. So always see the solution for the first time. If you are unable to do it, try it by first time. If you're unable to do, don't feel shy, don't feel hesitant, don't feel frustrated. See the solution, write down the program. Then second time, try to do it without looking at the solution by yours. So that's for the point I told you that in a journey, first you experience it, then you can do it easily. So the more problems you saw, the more solutions you saw, you get the new ideas. All right. Most of the people stop in the beginning only, beginning of their career, beginning of their programming, because you are unable to get the ideas how to write on the program. Nobody will get the idea how to write on the program easily. Nobody will get it. If your friend is doing it faster, means already has spent time in schooling only. Okay. He is smart. No, he is not smart. He has spent time already in schooling. He did some programming. You are doing in engineering. So you are a little late. No problem. Okay. Got it? So never get discouraged if you are not not able to write on the program. See the solution. Second time, after 1 month, you do the same thing. Right? You write on the same program once again. Without looking at the solution, you write it. So now you know the solution. Right? So this is the way of learning. See the solution first time. Second time, don't see it. Third time, do it again. Then whenever you are free, try to write on the programs that you already know. All right. Got it. So that's all. This was the session. Now, already I have more slides about algorithms also. Little bit of algorithms, like algorithm and the type of studies and all. I have not discussed about the algorithms as a subject. Okay, so that's all. We end our session here.
Thank you so much, sir. It was a knowledgeable session. And indeed, you are a living example of expertise and knowledge.
Rightly said, Aaron. And the students were like, "So we don't want this session to end." And we can see the chat box flooding with a lot of questions. So as we are running short of time, like maybe we'll be able to take up a few questions. And there were a quite knowledgeable and technical questions in the chat box. So sir, with your permission, can you have some of them, please?
Yeah, sure.
So one of the question was, we also have data structures for data management and database, like the B+ trees and similar ones you mentioned before. So when the requirement of database changes and it grows and needs new complex ways of storing the data. So how you think we can achieve it while still maintaining the low latency of data retrieval from the database?
Anini, can you repeat the question? If the data size is increasing?
Yes, sir. Like if the data size is increasing and we need more complex ways of storing it. So how can we still achieve it by maintaining the low latency of data retrieval?
Yeah, actually, there are two. The conventional method of storing the data is a relational model. That data was stored in the tabular forms, organized form. Data was having the relationship with one another in the tabular form. But now we have the NoSQL databases. We have the databases called document databases. So it is unorganized data, and everything is indexed. The data is indexed. So suppose one person data in a Facebook, if you take the example of Facebook, one person's data, one profile, okay, his name and his location, and okay, if you take LinkedIn, suppose, name of a person, his location and his education. All right. So like this, the data can be indexed in various ways. Now, if you search based on profession, also you can get the person. Search based on name, also you can get the person. Search based on location. Now you want all the people on a LinkedIn on from Chandigarh and from particular locality. If you mention that, you can get the people from the Facebook database. So NoSQL database is used where the indexing is done upon the same data on various keys. Indexing is done. So that indexing is multi-level indexing is done. So that is B trees and B+ trees are used actually. So I have a YouTube video on B trees and B+ trees. There is a video on it. I have given a detailed discussion on how the B trees are useful in databases. Like you raise a good question. I was telling you that arranging the data on the hard disk is nothing but a database, right? How the data is mostly organized on the hard disk, it is done in the form of a tabular form only. But for fetching the data, B+ trees are used there. So B+ tree is also a data structure, But that is for the permanent storage. It is not for RAM. It is not for RAM. B plus trees doesn't work in RAM, right? So databases also have the data structures. Like hash tables are also used. B plus trees are also used. B plus trees are nothing but index only. Next, okay.
Yes, sir. Thank you so much, sir.
Sir, one of our attendees have asked a very interesting question, that you are a CEO of an e-commerce consulting firm. How did someone with MTech in CS and so involved in DSA find himself in consulting, cloud, and strategy?
Maybe I didn't get your question.
Sir, the question is that you have done MTech in CS and you are you are a DSA guru. So how you find your path in consulting, cloud, and strategy?
Means you're talking about the career related to cloud.
Exactly, sir.
Actually, okay, if I understood your question properly, see, in academics, actually you study core engineering subjects. If you talk about cloud, like maybe in latest syllabus in your engineering syllabus, maybe having the cloud computing also as the subject, and cloud related subjects are also there. But actually, cloud comes down to networking. Basic thing is networking. So as an engineer should start learning from networking, not directly cloud, right? So in the latest trends, we find mostly the new technologies are coming up. The technologies will be keep on coming. Every day new technology comes. It is just like every day new car is launched. But for learning car driving, you have to learn on that Maruti 800 only, right? So that's what in engineering you are learning the basics. Like you are learning Maruti 800, right? So for teaching you how to run a car, to make you a perfect driver, Mercedes should not be used or Audi should not be used. Like that is not the requirement. That Audi or Mercedes or BMW, whatever it is, it's a technology. So every day a new thing comes and you will be learning about that. Right. So building a career in your in as a cloud consultant or anything, so you have to start your journey as a I should say, you may not get a direct job or you will not direct job opportunity in that area unless you are doing some specialization. You have some specialized subjects in your curriculum itself, in your engineering itself, right? If you don't have that, so don't worry about that career. It will take time for you to build up your career, like in 3 years, 4 years. If you are getting an opportunity to get a job in that direction, then you can grow in that area.
Thank you so much, sir, for answering my question.
Yeah.
Thank you so much, sir, for such a great session.
Like when I studied Pascal. Even C language was not there. Right? Even C language was not there. Now working in cloud is a big journey, very long journey, right? So even for you also, it will be similar. Yeah, that's all. We end here. Nice talking to you guys.
Thank you, sir. Thank you for such a great session. Now I would like to invite B. Peasley Chand, sir, Dean of Academic Affairs and Branch Advisor of Chandigarh University, to address us with his insightful words along with the vote of thanks and present the token to our guest of honor.
Oh, thank you, dear. Thank you for inviting me and giving me an opportunity. So, sir, I couldn't completely attend your session because I was traveling a lot. But the feedback that I got from the students through the group and also through personal message was tremendous, actually. So let me thank you for giving your valuable time, also discussing with the students on these data structures are highly important. Students, I'll tell you one thing. I'm on the way to meet the CEO and CHRO of Hanu Software. They are trying to recruit 5,000 students in next 2 years. Okay. Am I audible here? Yeah, 5,000 students.
Yes, sir.
And Today night, my dinner is with them. I am just on the way within.
Sir, I guess there's a network issue from your end.
5 minutes, I'll be catching up with them. They are ready to take 1,000 plus students from Chandigarh University. The only skill that they are looking for is government. They have told, and they are. Am I audible?
Yes, and now you're audible. Please continue.
Yeah. So this Hanu software is ready to take 1,000 students from our university who can write clean and neat codes. These are the only requirements with this people are asking. So opportunities are plenty, and this is something. Some knowledge about data structure, database management system is something really required if you want to crack some placements with dream companies actually. So with this intention, IEEE Chandigarh University is arranging a lot of activities. Please take part in all these sessions, and experts like Sir can really give you the real thought of real sense of what you have to learn and what you have to study. Thank you so much, dears, and thank you so much, sir, for joining us. And I would like to meet you physically very soon in the campus also, sir, for having some good sessions with our students. Thank you,
Sure,
Vaibhav,
sir.
and over to you.
Thanks a lot, sir. Sir, we're once again requesting you to kindly present token of appreciation to our speaker.
Vaibhav, thank you so much, and thank you, Abdul Bari, sir, for gracing this particular online session in the evening. And this Tech month is getting a lot of prominence. I was happy to see almost close to 250 students who have participated in the evening for learning about data structure. So your session was really enlightening us, and thank you so much, sir. And let this association be a beginning, and let us learn with sir together so that we can achieve our goal of getting some dream placement for the IEEE members also. Thank you so much, sir. Vaibhav, over to you.
Thank you all. Thank you all of you.
Thanks a lot, sir. Once again, it was, I believe that people are also requesting you to kindly visit our campus once again. And I believe that it was really, really a wonderful session. Thank you once again for devoting your valuable time. And it was one of the best sessions, as I believe that the people were really very much enthusiastic in order to have conversation with you. So once again, sir, on behalf of whole IEEE Chandigarh University, I would like to thank you for devoting your valuable time, including that. Thanks to all the wonderful audience, team members, all the anchors, Shruti, Abhishri, Aryan, and all. A great job, guys. So once again, thanks to each and everyone. Thanks to our branch controller, Sugandha ma'am, Sham sir, branch advisor, and everyone, those who have joined our session. So bye-bye. Take care. Signing off, Vaibhav Singh.
Right.
Have a nice day. Soon we are going to come ahead with
And before leaving, let's have a group picture together.
Yeah,
so
sure,
I request
sure.
everyone to please turn on their cameras. We'll just take a 1 minute.
Thank you, Shruti, for reminding me. I was just going to miss this part. So it's an honor for all of us to have a photograph with you, sir.
You're welcome.
We are also
Okay,
having a
right,
branch
we'll understand.
ma'am.
I see.
If we can show a cheese, please.
Oh.
How about? Thank you, sir. Once again, a big thanks.
And guys, before leaving the meet, do not forget to submit your valuable feedback. Valuable feedback form is shared in the chat. Please submit your feedbacks.
And guys, the feedback is really important for us because we are able to get and find out where we are lagging, right? We know our speaker is amazing today. Only the coordination part or anything you want us to convey so that we can make the session, next session to be more fruitful for you in case of coordination, in case of anything. If we miss out anything, please do share your feedback. And there are surprise, like suspense things are also there. So do check our website for that. So yesterday's result is also are also prepared. So our team is all set to release soon. So maybe we will be releasing into some suspense zone of midnight.
And guys, for certificate part,
sir, and it was one of the amazing session I can ever attend in case of DSA especially.
And guys, for certificate part, You all people will be getting certificate as soon as the Tech-A-Month 3.0 ends. And don't worry for the certificate. Definitely, you'll be getting whatever time you're contributing. But instead of certificate, you should much more focus on your learning part, because which is the most important thing in order to get placement or anything you want to do in your life, right? Learning is the most important thing. And guys, we are going to reveal, not reveal, we are going to bring so many good speakers. Rather, I should say it has become a fan fest for CSE people, not a fan fest where we are going to call speakers like you know what I'm talking about, but instead
Sir,
CSE fan fest,
do not reveal the speakers.
yeah, we'll not be revealing the speakers, but this is definitely a fan fest for all the people from CSE, and definitely those who are interested in the field of coding, DSS and all, right? So don't forget to join our other sessions, and you can visit our website. Technical team, kindly share the website link.
Manas, yes, share the website link. Guys, please visit our website.
And do follow our social handles, because you're going to get great insights. And about this Tech-A-Month 3.0 is all about goodies also. So this is the right time to earn some good goodies and swags, and rather I should say give a flex in college, right friends? So you will agree with my point. So it will be really great opportunity for all of you. And we're also going to have offline sessions with some I should not say some wonderful
Really great speakers, yeah.
Yes, sir.
We can't reveal it for now.
Just putting a pause. Just putting a pause. A big surprise for all of you.
And more things to add over here. I just want to contribute more in the suspense. So not only CSC, if you stay tuned with our website, there will be plethora of opportunities for all the different streams, right? So this time we tried our best to bring different insights, multidisciplinary events, plus a suspense zone of movie night, culture night, many more things, right? And this time Tech-A-Month is not only about knowledge. To add on, we are just like a Santa Claus bag full of surprises and goodies for you. So now this time we always get audience who are really happy to learn a lot, but somewhere the feedback we get, we need to have some association or belongingness. Now this time we are the Santa Claus for filling up that with the goodies too. And it's really amazing when the students who are joining, they are continuously WhatsApping us. Like I recently received one idea from Arvind Khoda, right? And this was really interesting. So same way, guys, do share your inputs, do share the things on your social media. So we will be monitoring everything, and best 3 top story writings, which is being done after the event, will be getting surprise goodies.
And guys, there are a few questions as how can I join you guys? So basically there's only one thing in order to join us, that is active IEEE membership. And for that, we have already created groups. So I believe that you must have registered. Guys, am I audible?
Yes, sir, you're audible now.
So I was saying that don't forget to join the WhatsApp group, because we are going to release the form how to take IEEE membership. Because this will be really a wonderful interaction, a wonderful opportunity for all of you people in the session to be IEEE member. It will be really a proud moment for all these people, those who want to join IEEE.
Yes, sir.
And to add related to IEEE, guys, yesterday we have announced there will be 3 full IEEE sponsored memberships, depending on to your scores, what you'll be getting in your competitions, quiz-a-thon, and number of opportunities are there to like deliver the things, and accordingly how you react, definitely you can grab goodies from us. Yes, IEEE membership is paid, and currently our branch is offering you 50% scholarship for that. So our website will be having the link, right? I hope Manas, you have already added the things, and please stay tuned with our social media handles and our website. That is the easiest way to approach this.
Team, you can wait here for 2 to 3, 4 minutes more, and then you can close the session, right?
And guys, put a reminder on your calendar that you have to daily attend the session of Tech-A-Month between the 7 to 8, and please put a reminder on your calendars.
Just one more surprise from my end. Person with 100% or 90% attendance in Tech-A-Month 3.0, that means attending all 30 of our event, will be getting a big surprise from IEEE, a bumper surprise, not a big, a bumper surprise, right?
Just like you get +3 marks in every subject if you have 90% of your attendance.
And please don't underestimate our words. We are हम अपने words को कभी झूठा नहीं साबित होने देंगे. So please stay tuned with us.
And guys, not only goodies, not only bumper offers, we do have paid internships, right? So there are n number of sessions, n number of events, right? And one of the biggest event we are going to have is related to Dash. And the outcome will be MacBook. So you need to complete this Dash. If anybody can, so he can get the offer right away. Core team is not allowed to answer this. So if you are a Mac fan, if you are an Apple fan, there are n number of things you can grab it to.